Welcome to the Thailand International Mathematics Olympic mock examination 2021 and 2022. This is for the student of senior secondary group. Now, there are one thing that I would like to remind you on this examination. Now, this mock examination, just like the real one, consists of 5 parts with 6 questions in each part. So in total, there are 30 questions. You need to finish this 30 questions within 90 minutes. So as you may know, you have only 3 minutes to finish each question. So it is advisable for you to stop working on this question if it takes you too much time of doing this. Even if you are guaranteed, if you know that you can finish it, but it takes too much time, I will advise you to stop working on this question and to work on the next question until you finish all other questions. Because time is of its essence in this examination. There are so many questions in here, so I would like you to remember you cannot spend more than 3 minutes on each question. Okay? So without further ado, let's go to the first question of this paper. Question number 1. Now, there are many competitors in the Taekwondo competitions. Each competitor will play 25 rounds, and the score of each games are located in the following ways: 2 points for a win, 0 for a loss, 1 point for a draw. Find the number of possible score of a competitor after the competition is complete. Now, in here, there are some keywords in here. There are many competitors, which means that there are many winning and many losing, and even more draws. So, which means that there are all the combinations are possible. All the combinations of winning, losing, and drawing is possible. Now, if we do not have that much people in here, then the number of winning and losing and drawing may be limited because because for example, if there's only 2 people here, if one of them is win, then the other is lose, then no one is going to be draw. The keyword in this question is there are many competitors, which means that we can safely regard them that is all combination of winning, losing, and drawing for this 25 rounds is possible. Okay, this is very important. So now we want to know the number of possible score for all the competitors. So let us consider range of the score. Now, if we have a competitor which is very, very bad, so it will all of them are lost. If just lost all of them, so what's the point for this competitor? Of course, 0, right? 0. How about if a competitor is so good that they win each and every one of the competitor, each and every one of this match, then they will get 2 times 25 is equal to 15. So we know that at first glance, that all the points that is possible for this competition lies within this range from 0 to 15. 50, okay, from 0 to 50. Now, the only thing that we need to think about is that, is there any point in which it is impossible to get? Now, this impossible is not because there's not much competitor. As we have stated, there are many competitors, so that all combinations are possible. But sometimes some point is impossible to get. Now, for example, in here, if instead of 1 point for a draw game, we allocate 0 point for a draw. So it's either 2 for a win and 0 for a loss and draw. So for all this competition, it is impossible for you to get an odd number of score because all the competition, either you get 2 or you get 0. These are all even number. So it's impossible for you to get a odd number. If the drawing is not, you will not get 1 point for drawing. Okay, so for this kind of question, sometimes it is impossible to get a certain score. But in this case, fortunately, it is not that case, because from the 0 point to our 15 point, we can always think of a situation in which you can gain the point. Now, for example, now the 15 is easy, 25 wins. Now, how about 49? Now, let us give you some example. How about 49? 49 is just the same as our 24 wins and a 1 draw. Then this will get you a 49. How about 48? And 48 is just 24 wins and 1 loss. So this will be 48. And for 47, you just keep on doing this. It's 23 wins, 1 draw, and then 1 loss. And then it will be 47, and so on and so forth. So it is very easy to see that you can always change a win to a draw to have your score lowered by 1 point. And you can always change a draw to a loss to have your score lowered by 1 point. So we can do this all the way up until the point 0. So all points, all score within this range is possible. All score is possible. So how many possible scores are here? You can get from 0 to 15. So all the possible score is actually 51 score. So remember, from 0 to 50, there are 51 different scores. So our answer is 51 in here, in this question. Okay, the answer is 51. So this is for our first question. Now let's go to our second question. Thomas go east for 20 kilometers and then go south for 42 kilometers and then go north for 7 kilometers and go west for 8 kilometers. Now it looks complicated, but it's very simple. Now, so in here, first of all, it go east 20 kilometers, go east this way, 20. And then it go to the south for 42. So it will go to the south for 42. And then it immediately go back up for 7. Immediately go back up for 7. So now it comes up to this. And finally, it will go west for 8. So it will be go west for this. So now here comes my question. Now, at the very beginning, it starts from here. And it ends in here. So what's the distance between these 2 points? What's the distance between these 2 points? Yes. Of course, but I'm recording this video now, so you can get the link of this video later. So you don't need to record it. If you want to record it, yes, of course, you can. But because we are recording now and you can get a copy of it later, so you don't need to, okay? So notice that in this question, we can calculate this distance by simply recognizing this is a right angle triangle in here. So in total, because it's go south 42 and then go north 7. So in total, it's just in net value, it goes to our south 36 because it goes to our east 20, and we go back to our west 8. So in total, it will be going to our east 12. So by this, we can see that this is a right angle triangle. This is a right angle triangle in which it will have a length of 12 at its base and 36 at its height. So by Pythagoras theorem, we can find out the value of this length. So remember that the Pythagoras theorem says that the length of our hypotenuse is equals to the root of the square of our first length plus the square of our second length, right? So by the Pythagoras theorem, you know that this would be our answer. Now we know that since for 12 and 36, they are all having a common multiple of 12, so we can take them out. And hence we get it will be 12 times root of 10. So our answer is 12 times root of 10. Okay. So let's go to question number 3. I thought it was 25, not. Oh yes. Yes. I'm sorry. Yeah, this is a huge mistake. Now, now because of this, we need to calculate it carefully. So for our first number, it would be equals to 144. And the second number, because it is the square of 35, the square of 35 is equals to 1225. Yes, you're correct. So what is the sum of these two values? What's the sum of these two values? The sum of these two now, because we already have done, okay, we have done all the things we need for our diagram. So in order to have more space, we get rid of our diagram. And now we know that this is 1225 plus our 144. So it will be equals to the root of 1369. The root of 1369. So we can calculate the root of 1369, and we will happen to know that this is actually equals to 37, right? So the answer is actually 37. Yes, thank you. Thank you. Yes, thank you very much. So this is the root of 1369. Now, do remember to take the square root of it. Pythagoras theorem says that the square of the hypotenuse is equal to sum of the square of the two other sizes. So we need to take the square root of it. Okay. Wonderful. Now let us go to our third question. Our third question, it would be equal to something like this. Now I will write it in the usual horizontal. No, it is a vertical sum. So it have our vertical sum C plus B plus D plus A, and finally D plus C plus A plus B. Okay, so we want to sum up these four numbers, and we know that what the sum is. The sum is 64438. The sum is exactly equals to 64438. Now, but instead of calculating them directly, now we want to calculate it digit by digit. We want to calculate by digit by digit. Now, what is the sum of the unit digit? Well, the sum of the unit digit is equals to A plus B plus C plus D, right? How about the 10th digit? If we sum up all the 10th digits, it will be equals to, again, A plus B plus C plus D. Now, but this time, do remember that because these are the 10th digit, these are the digit represent 10 in here. So instead of A plus B plus C plus D, it is equal to 10 times A plus B plus C plus D. Now, the same thing goes for our 100th digit. Again, the digit, if you try to add them all up, it will equal to A plus B plus C plus D again. But we do remember that all these digits are representing 100 digit here. So instead, they are equal to 100 times A plus B plus C plus D. And finally, for our topmost of our leftmost digit, which we will call the 1000th digit, the sum of it will be equals to our, now let's use another color. So let's use pink. So the sum of it will be equals to our 1000 times A plus B plus C plus D. All right. So now we have two answers. One is we compute the value of this the sum of this four integers, and to get our answer is 64,438. But another way of doing this is we compute this number digit by digit, and we find out that this is equals to 1,000 times A plus B plus C plus D plus 100 times A plus B plus C plus D plus 10 times A plus B plus C plus D, and then plus A plus B plus D plus D. Now this is a mouthful, right? But in reality, this is because they all have a common factor here. They all have A plus B plus C plus D as a common factor. So we can take them all out and take all this out. And hence this number will be exactly equals to A plus B plus C plus D times 1111. So now we have two equations. While we have equality, A plus B plus C plus D times 1111 is exactly equals to 64438. And hence, if we divide both sides by 1111, we will immediately get the values of A, B, C, D. So what is A, B, C, D? A plus B plus C plus D is equals to our 64438 divided by 1111, and hence it will equals to 58. This is our answer. Okay. So let's go now. For question 3, it asks you what's the meaning of digits? What's the meaning of each of these digits? I think it's impossible for it must be less than yeah, that's strange. Yes, that's strange. Yeah, this is impossible. Yeah, you're correct. This is impossible. How strange it is. Again, not a good question, but this is the way of doing this question. Okay. Well, thank you very much. This is not a good question because this is impossible. But if now you know the logic of this question. Okay. So let's go to our question number 4. Now let's go to our question number 4. For question number 4, the October 14 of 2021 is first day. Which day of the week will be October of 18, 2034? Now, again, this kind of question is, all you need to do is to calculate how many days have passed for them to go from our first date, October 14, 2021, to our last date, October 18, 2034. So as long as you know how many days have passed, and then you can calculate it as in the number of weeks and the day remain. And you know that if you have passed a week, you does not change the day of the week. So all you need to take care of is the remainder when the remainder of the number of days when divided by 7, the number of days within one week. And then after you get the remainder, and then you can try to count from our first day up until to the days that we want. So this is always these cases. Now, first of all, let me count the easiest thing. So if we have our 14th of 10, 2021, I would like to know what would be the date of the week. Now, because we know that this date of the week is Thursday. This day of the week is Thursday. Okay. So I would like to know what is the day of the week for 2020 of the October 18, 2021 for this one. Now, that's simple because this is just 4 days later. It's just 4 days later. So we can simply count it. So we go from Thursday to Friday to our Saturday, and then to our Sunday, and then to our Monday. So we know that this day must be Monday. Okay. So this is the first step. Now, why we want to do this is that we want to align the number of days, the date with our target. We want to align them. Now, once we align them, we can now shift very quickly. Now, if our 18th of October is Monday for 2001, what is the number of days for what is the day of the week for our 18th of October 2002? What is the day of the week? Now we know that in here there are 4 days. But how many days have passed from our 18th of October 2001 to 18th of October 2002? It is 365 days, right? Exactly a year. Now that is why we want to align the ending date. We align it, and hence we make sure that we can count it year by year. But now we know that 365 days is exactly equal to 32 weeks plus 1 day. Now the weeks is not important at all, because we all know that after a week, if you are in Monday, after a week, it will always give you back a Monday. Okay. So this is not important. All is important is the 1 day of this, 1 day extra of this. So it will go from Monday to Tuesday. Now, of course, I would not ask you to actually count it year by year, right? Now, well, you can do this. This is nothing that you cannot do this, but now actually we can count it in groups. We can count it in groups. So now starting from 2021, so 2022, now let us compute it in batches if we group them together. Now, how about 2023? Now, because the end date we know that is October 18 of October, so we now no longer concern ourselves of the date of the day and the month of that date. So how about 23, and how about 24, 25, and 26, and 27, 28, 29, 30, and then we will have our 31 and 32 and so on and so forth. Now, of course, after 31, then we still have our 31, and then we have our 32, and then 33, and finally 34. Now you don't really need to count them. And if you are good at arithmetic, you can directly compute them. But in here, I just demonstrate how to do this. Now, because we know that for our 2022 to our 2023, how many days will pass? Again, it will pass. There will have 36 days have passed. 365 days, okay? 365 days, and again, this is 52 weeks and with one day extra. So again, we know that the week is not important, the day is important. The day extra is important. So from 2023 to 2024, again, it will just the extra 1 day. Now, but for 2024 to 2025, this is something strange because 2024 is a leap year. So it actually have 2066 days, 366 days, right? So we know that it will have 32 weeks and plus 2 extra days because of the year. So we need to take them into account. So again, after this, for our 2025, 2026, 2027, they are all normal years. So you just add 1. But for 2028, again, a leap year, so we add 2. So this is again from our 2029, 30, 31. They are all normal years. So we just add 1. And now from 2032, we add 2 because of leap year. And then finally, 2033 is a normal year. So we just add 1. So how many days have we added? Now let us combine them together. So this, we start 1, 1, 2, 1, 1, 1, 2, and then 1, 1, 1, 2, and then an extra 1. So in reality, it means that if we start from this date, and we want to go all the way to our 2034, it will get exactly 3 times our 1 plus 1 plus 1 plus 2. And that is equals to 5. So we know that this is exactly equals to plus 15. But plus 15 is equivalent to what? Plus 1, all right? They are equivalent to just simply plus 1. Because it means plus 15 means that you have 2 extra weeks and 1 extra day, 2 weeks and plus 1 extra day. So for 2034, that day will be 1 day after our Tuesday, and hence the answer will be our Wednesday. Okay, so our answer for this question will be Wednesday. Now, although I only apply the method of counting the extra day for every year on the later part of the solution, you can see that I can, of course, apply this on the earlier part of the solution. So instead of separating into 2 parts, you can combine them all within the same framework. So I will leave it for you to figure it out. Okay, but the ideas is in here. So this is question number 4. Question number 4. The answer is Wednesday. Okay, so now let's go on to question number 5. Find the number of 3-digit positive number with sum of digits equals to 12. Now this question is hard. This question is hard. Now there are 2 major ways of doing this. The one is to use inclusion, exclusion. Now, there's 2 major ways of doing this. The one is the hard way. We consider this 3-digit number as the following. We want to consider the number ABC as a 3-digit number such that A plus B plus C is equal to 12. Now, but we know that we have combinatoric tricks to find out how many ways can we write a number A, B, C into 12? Yes, we can. We can do that. So by this, we can get all the different combinations, but do remember that each of this number cannot be greater than 9. So we need to take out some of the probability by means of inclusion-exclusion principle. Take out the impossible by inclusion-exclusion principle. And then we can calculate this using the combinatoric tricks. Now, if you do want to use this method, that this is completely fine. This is completely fine for you to use this method, making use of the H distribution and using inclusion-exclusion principle to do this. Now, this is completely fine. But the easier, I would like to think that it's an easier method to do this is just by direct counting. Now, well, 12 is not a very big number, right? So we can directly count the numbers of it. So in here, I will use the direct counting method. Now, I know that some of you may think that way. Direct counting seems very not mathematical. It seems so simple, right? You just count. It is so simple. It's not so sophisticated. Now, but I would like to remind you that in the mathematics, especially in competition, what's important is you get your result. This is not whether it's elegant or not. Okay. So by direct counting, you can immediately count how many different ways that you can get our 12. Okay, so now let us list out all the different ways for you to get a 12. So you can have a 0, we can have a 0, 0 plus 3 plus 9. So this is a 12. And another with 0 plus 4 plus 8, it is equal to 12. And 0 plus, now in here, I'm assuming that the numbers on our right is always greater than the numbers, always greater or equal to the number on our left. So again, this is equal to 12, and 0 plus 6 is also equal to 12. So by this, we can compute all different combinations. So now if the last digit is equal to 1, so it will be 1 plus 2 plus 9, and then I just skip the plus equals to 12 because now, as you know, this is obvious. 8, and then 1 plus 4 plus 7, and then 1 plus 5 plus 6. And then now we go to our 2. 2 plus 2, 2 plus 2 plus 8. And maybe I use a different row to compute it. Now these are all sum up to 12. Now later on, we will compute all the different combination of this. So we still need to work on that. There are still many works to do on that. So this is a 2 plus 2 plus 8, and then 2 plus 3 plus 7, and then 2 plus 4 plus 6, and 2 plus 5 plus 5. And then we go to 3, 3 plus 3 plus 6, and then 3 plus 4 plus 5. And finally, 4 plus 4 plus 4. So these are all combinations of all the digits that can be added sum up into 12. Now let's compute how many different ways can you rearrange this digit such that it is a 3-digit number. So for our 0, 3, 9, how many ways can we rearrange it such that it is a 3-digit number? Now, remember that the 0 cannot be placed on our first digit. So it must be either line or 3. So there are only 2 ways of playing that, and then all other will be 2 times 2 times 1, and hence it will only have 4 different ways of doing this. Now, the same thing goes for the next one. in fact, same thing goes for all this one. Now, the last one is interesting because there are only two ways of doing this. Either you are 660 or 606. So there's only two ways of doing this. Okay, depends on the position of 0, whether it's on the unit digit or in this 10th digit. So for our first, starting from 1, now this number can rearrange between these 3 digits. So there are 6 different ways of doing this, 3 times 2 times 1. The same thing goes for our 138, 147, 156. These are all 6. Now for our 228, because 2 and 2, they are the same. Because 2 and 2, they are the same. So all it depends on is the position of our 8. So there's only 3 ways of doing this. Either place it on the 100 digit, the 10th digit, or the unit digit. Now for 237, again, 6 different ways of doing this. And here, 6 different ways of doing this. And here now, again, it depends because of 2, 5 are the same. So all it takes is for you to count how many different ways can you place your 2. So there's only 3 ways of doing this. The same thing goes for our 336 because we just count the number of ways that you can place your 6 here. And then again, you'll be 6. And there's exactly 1 way that you can get our 444. So by this, if you sum up all this number in blue, then you get your answer. So let's sum them all up. So in here, it will be 6 times 4 is 24. 24 plus our 14 is equals to 28 for our first row, first column. For our second column, it will be 366 as 36 is 18 plus our 9 is 27 and again is 28. So in total, it will be equals to 28 plus 28, and hence it would be equals to 56. Now, again, this is the most easiest way of doing this. Now, in here, what I mean is easiest is not, this is not tedious, although it's not that tedious, I just hand calculate it. But it's the most easy to understand method. If you do not use this method, instead you would want to use the inclusion-exclusion principle to do this, fine, very good. But do remember that it takes a lot of consideration. And if you're thinking about this question, it still takes you time. So sometimes a direct method is the best, especially in competition. Okay, so this is question number 5. Now let's go to question number 6. On the left-hand side is, oh, yes. Yes, my arithmetic is very bad, okay, it seems. So this is 38. So in total, it will be 66. Thank you. Okay, so this is the ideas of question number 5. Now let's go to question number 6. Use decimal number system to represent a quaternary number 4026, which is strange. Now, the record will be sent to your email. I think I will not send the video directly to your email, but I will send the link to the video. I think it will be either be email or through something like WhatsApp or other means or a text message, because it will be much easier. Okay. Okay, so in here is we have coordinate number. So this is because in here we see that this is the downward is a 6, which is very strange because the Chinese translation says that this is a 5. This is the number of base 5, but which is not true. Which is not true because this is clearly a number of base 6. So what do you mean by number of base 6? a number of base 6, it means that each of these digits represent a power of 6. So for our first digit, it represents 0 power of 6, or in other words, it is equal to 1, okay? So it represents 1. So for each of this number, it represents 2 times 1. But for our second digit, it represents 6 to the power of 1, which is equals to our 6. And for our third digit, it represents 6 to the power of 2. So each of this four represent 4 times 6 to the power of 2, and hence it represents 36. So in summary, this number representing a 4 times 36 plus 0 times 6 plus 2 times 1. And so this number is 4 times 36 is equal to 144 plus 0 plus 2. And hence our answer is actually equals to 146. Okay, the answer is equal to 146. I mean, this is some typo here, but the answer is, these are some typos in here, but the answer is correct. Okay. So this is question number 6. Okay, so let us go to our next topic, which is the arithmetic. Okay, let's go to the next topic. Find the value of x such that this is equals to the root of x is equal to x minus 30. This question is, although this is algebra. Now, this is an algebra problem. So in here, what we want to do is to change your variables. Because the root of x is very difficult to consider. Now, let us change it into other things. Let us say that the root of x is called y. Let's call it like this. The root of x is called y. Now, notice one thing. Since y is equal to root of x, this automatically be greater or equal to 0. So y must be greater or equal to 0. Now, this is very important. Later on, we will see why this is important. Now, if that's the case, let us rewrite our equation. Our equation now becomes something like this. Y is equals to y squared. Now, because y is equal to square root of x, so y squared is equal to x. So y is equal to y squared minus 30. Or in other words, we can rewrite it as in the following thing. Y squared minus y minus 30 is equal to 0. But do remember that this quadratic equation can be factorized. Can be factorized into following form. So it will be y minus 6 times y plus 5. Since this is equal to 0, which means that at least one of this factor must be equal to 0. Either y plus 6 minus 6 is equal to 0 or y plus 5 equal to 0. So it means that our y must be either equal to 6 or our y is equal to negative 5. But again, y equals negative 5 is impossible. Rejected. Just like what we have talked about. Why? Because our y is always equals to a number which is greater than 0. A square root of a number is always positive. So this cannot be done. So we know that y is equal to 6. And finally, we will subtract back to our solution. So we know that the square root of 6 is actually equals to, square root of x is actually equal to 6. And hence, x is equals to 36. Okay. So this is how we do question 7. Okay, so let's go to our next question. Next. The next question again. Now, whenever we see some two variables equation behave like this, we should smile. Why? Because it is a very well-behaved solution equations. It is very well-behaved. What does that mean? Because all the variables are separated, we can rewrite this as the following. We can rewrite it as x squared plus 14x plus our 49 minus our y squared minus 12y plus 36. You see? The things on our left-hand side is the same as the thing on our right-hand side. The variables separate itself. The x are nothing related to y, and y has nothing to do with x. They are not multiplying together. There is no x times y term in here. So since they are separated, we can separate like this. And why we write it like this is because now you realize that the first term of this difference, the first term is exactly equal to x minus 7 squared. And the second term is exactly equal to y. No, the first term is equal to x plus 7 squared. The second term is equal to y minus x squared. Okay, so we are almost done. The only thing left is we need to know the difference of the square. The difference of the square. Now, what do I mean is that our a squared, when it's minus b squared, it can always be written as a minus b times a plus b. So in here, we called our a x plus 7 as our a and our y minus 6 as our b. So we can rewrite our equation. After we rewrite it, and this would be our answer. X plus 7 minus y plus 6. And then x plus 7 plus y minus 6. And hence the two factor will be x minus y plus 13 times x plus y plus 1. Okay, so this is our answer for question number 8. Okay, so question number 9. Now, question number 9, we need to make use of a property for our logarithm function. The property namely this property. So if we have a log number of a plus the log of a b, it will be equal to log of the function a times b. Now, this is one way of writing this. The other way of writing this is the following. The log of our function a, minus the log of our number b, can be written as our log of a divided by b. So a logarithm function change a multiplication into addition and change a division into subtraction. Okay, now in particular, we will use this part. We will use this part. And we apply this to our function in here. So now, because they are the difference of it, we can change it into a division. So it will be log of that. It is understand that the base is equals to 2 in this case. So it will be equals to log of 12 divided minus 14x divided by x, which will be equal to 4. But that's because it is a log function and the other side is an integer, we can do a reverse of log. We can do a exponential of it. So we know that by this 12 minus 14x divided by x, it will be exactly equal to 2 to the power 4, which is equal to 16. Or in other words, 12 minus 14x is equal to 16x. But then it is very easy to see that our 30x is exactly equal to 12. Or in other words, if we divide both sides by 3, we know that 10 divide both sides by 6, we know that our 5x is equals to 2, or x is equals to 2 over 5. Okay, so this is our solution of this question. This is our solution of this question. Now, but one thing that I would like to mention, is that this question, just like the last one, is problematic. This question, just like the last one, is problematic. Again, this is not a good question. Why this is not a good question, you may ask? It's because for a logarithm function like this requires that both of this is actually, actually it is okay for this one. It's okay. No, I just retract my wording. Okay, so our question is equals to, our x is equals to 2 over 5. Okay, so now remember that whenever you finish it, do check that, because within this log function, this must be greater than 0. Again, because my arithmetic is not that good, so I misunderstand this as mistaking it as one of them is more than 0, but it's not. So this question is okay. So this is how we do question 9. Now let us go to question 10. Let's go to question 10. Find the coefficient of x squared in expansion of this. Now again, there are something which we call a multinomial function, in which you can write down the coefficient of any terms based on the base polynomial and its index. Now it can be done, but again, it does not worth your time. So what we are doing is try to use our basic distributive law to find out what exactly is this expansion. Now you may see that this may be this is very tedious. Now yes, I agree, but it's actually not that bad, because do we need to consider all the terms, all the coefficient of x greater than 3? No, right? We don't need to consider them. All we need to do is just to keep track of all the coefficient of x which is less than or equal to 3. As far as we have done this, we are good. So in here, if we multiply them together, we know that the least term is 1, because 1 times 1, and the next term will be equal to negative 4x, because it will be negative 2x times 1 and 1 times negative 2x. Now for our third term, x squared, now there are 2 different ways of doing this. You can either, you have the negative 2x, multiply them together, or you have 1 of the x squared multiplied to our 1, and vice versa, right? So in here, we will have a 2x squared plus our 4x squared, and hence our answer will be our 6x squared. Okay, so this is 4x squared. So once we come, excuse me, let me change, I think we rearrange something. So this is actually cube. Okay, so now let us consider the cube. Let's consider a cube. Now, how can we get a cube here? Now, there are 2 different ways. One is you multiply our 3x to the power, negative 3x to the power cube to our 1, and vice versa, right? And the left-hand side, this one multiplied by this, okay? Now, the other things to do this is our x squared to multiply to our negative 2x, and vice versa, right? So there are 2 different ways of doing this. So if we counted for our real one, it will get a negative 3 times x to the power 3. For our orange one, we'll get a -2 times our x to the power 3, but we need to count them twice because it appears 2 times. So in overall, it will be equals to -10 x to the power 3. Okay. Now, once we get to the x to the power 3, do we need to worry about x to the power 4? No. Why? Because those numbers will not multiply into a coefficient of x to the power 3 because they are too big, right? They have too much power order. So other than this, we'll just get a dot, 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 and we are done. So this is to the power of 2. So now we need to do a to the power of 3. Okay, so for this to have a power of 3, we can replace the first 2 by our simplification, right? We can replace our first 2 by our simplification, 1 minus 4x plus 6x squared minus 10x cubed and plus dot, 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 okay? So we replace the first 2 by our simplification, and then later on, we still have to calculate this, okay? We still have to calculate this. Now, let us compute it. Now, notice that in here, do we need to consider the coefficient of our constant term, or x1, x to the power 1, or x to the power 2? No, we only need to focus on the coefficients of our x to the power 3 now. So again, how can we get our x to the power 3? There are 2 ways of doing this. There are actually 4 ways of doing this. One is our -10x to the power 3 multiplied by our 1. The other is, of course, our x cubed on the other side multiplied to our 1. And then we also have our -4x multiplied to our x squared. Or finally, we have our -2x multiplied to our 6x squared. So these are all the combinations that you can get. So let us write it all out. So for our green one, the coefficient will be equal to -3x squared. Now, in case you don't recognize, in fact, the x squared, x cubed, you don't even need to write them out because intuitively this must be x cubed, right? So and the next one, or our orange term, it is equal to -4x cubed, right? So for our purple term, it will be equals to -12x cubed. And finally, for our blue terms, it will be -10x cubed. So if we sum them all up, it will be -3, -4, -2, -12, and -10. So what we get is -29. So our coefficient is -29. Okay. So this is how we do it. Now, if you are proficient with calculus, in particular differentiations, you may find that expanding the coefficient x to the power squared power x to the cube is exactly the same as you differentiate this equation 3 times and then put x is equal to 1 to find the constant term. Now, this is another way of doing this, but that way is a little bit more sophisticated, and hence we will not use it in here. But if you do know about calculus, you may try that method. Okay, so let's look at question 11. Let's look at question 11. It's known that x is a rational number, x is greater than 0, and x is equal to this. Now, the most important thing of this question is to realize that this part is just the same of the whole thing. Right? Because you just keep on repeating and repeating itself. So we can replace the part colored in green by x. So we can rewrite our equation as the following. X is equals to 5 plus 6 over x. Because we know that x is greater than 0, in particular, it is not equal to 0, we can multiply both sides by x. And what we get is x squared is equal to 5x plus 6. Or in other words, x squared minus 5x minus 6 is equal to 0. But this is the same as saying that x minus 2 times x minus 3 is equals, no, it is x minus 6 times x plus 1 is equal to 0. So because it is equal to 0, just like other cases for the quadratic equation, we know that one of these factors must be equal to 0. So we know that in here, either x is equal to 6 or our x is equals to -1. But you do know that x cannot be equal to -1. Why? Because it was given to you by our question. Because we already know that our x is greater than 0. So it cannot be equals to -1. So this one is rejected, and hence we have our answer x is equal to 6. Okay, this is our question 11. Now let's go on to question 12. Let's go on to question number 12. Given that x is a real number, find the maximum value of this function. Again, for this question, whenever we see finding the extreme values of a quadratic equation, we always use the same method, computing square. Now, computing square means that we want to rewrite the equation into a square of a linear equation and a constant. Now, in here, given we have this equation, now let's just rewrite this as the following. So we rewrite it as -x squared minus 14x minus 49, and then now in here, because we want to get the maximum value, okay? So it will be minus for the x minus 49. Oh, actually, we don't need to rewrite it because, well, if we take the okay, yes, okay. So canif, yes, okay. Okay, so we don't need to rewrite it. We can just look into it this way. Now you can clearly see that the part within our parenthesis is exactly equals to our x plus 7 squared. It's exactly equal to x of 7 squared. Now, usually, if we have a square like this part is always going to be bigger or equal to 0. Right? This part is always be greater or equal to 0. Whenever you have a number, no matter it's a positive number or negative number, its square is always a positive number, unless it is a 0. So the square is always going to be bigger than 0, unless itself in the middle, the content within the square is equal to 0. But since we are adding a negative sign at the very beginning, so now the whole equation becomes always smaller than or equal to 0. Because it's a negative of a positive number. So we know that this must always be smaller than or equal to 0. So what's the maximum value? 0, right? Because it cannot be a positive number. If it is a positive number, which means that a square is a negative number, which is impossible. Okay. In particular, we do know that when will it happen? This equation, this expression will achieve maximum when x is equals to -7. So when x plus 7 is equal to 0. okay, then it will achieve its maximum, in which it is equals to our, it will be equals to 0. Okay, so this is question 12, and hence we have finished our algebra. Now let's go to a number theory. Given that this number is a number which can which is divisible by 99. Now, remember that divisible by 99 means two things. One is it is divisible by 9. Again, we have some rules to do this, to figure out whether it's divisible by 9. And the second one is divisible by 11. So we also have some rules to figure out whether it's divisible by 11. So first thing first, for the rules that we would like to use is the sum of digits, right? So let's just look into it. So for our first number, the sum of the digits in this one is equal to 2 plus 0 plus 2 plus a plus 3 plus 3 plus 1 plus 2 plus b plus 3 plus 5 plus 6. It must, now, because the whole number is divisible by 9, so the sum of digits is also be divisible by 9. But if we sum them all up, you will find that the number it has is equal to 24 plus a plus b. This number must be divisible by 9. Okay. So here comes the question. What will this number be? Because it must be divisible by 9, so it means that a plus b either is equal to 3 or is equal to 12. Now it cannot be equal now because the next number that can make 24 plus a plus b equals to is divisible by 9, it will be 21. But it is impossible for a plus b is equal to 21 because a and b is a number less than or equals to 9. Okay. So this two, so we know that, okay, so this a plus b must be either 3 or 12. So because we want them to be small, so we want it to be equal to 3. But let's look at the other one. Okay. So for the divisible by 11, we have something very similar to sum of digits, but instead it was the alternate sum. Alternative sum. So instead of our summing directly, we separate them into two groups, and then we try to sum them all up in each group. So we have our 6, but sum up to our 3, to our 2, to our 3, to our 2, to our 2. And then we take the difference of the two groups. So we have 5 plus b plus 1 plus a. So our alternative sum will have the result like this. Or in other, I shall say it is the alternative sum. It will be equals to 2 plus 2 plus 3 plus 2 plus 3 plus 6 minus our a plus minus our a minus our 1 minus our b minus our 5. So this number should be divisible by 11. But what exactly is this number? Now, if you sum all the numbers before it, and you will see that this number is equal to 18 minus, so it will be equal to 12 minus a minus b. So this number must be divisible by 11. But what's this number? This number, it means that our a plus b, in order for it to be divisible by 11, no, notice that it is negative. Now this is not negative a, negative b. Now let me rewrite it. It should be like this. We gave you a bracket, so it's much easier to see. So in order for this 12 minus this to be divisible by 11, so either this will be equals to 1, or this is equals to 12. There's only two ways of doing this. So because we need to satisfy both of it, so we can see that there's only one way for this to be true, is that our A plus B is equal to 12. There's no other way. There's just one way. So hence this minimum value is of course equal to 12. Okay. So now let's just go to our question 14. Now our question 14 is actually not a very difficult question, but in fact it's a question which is itself a much more like a rearrangement. Now what does it mean? Now we want this to be, we want our number in green part is an integer. Now let's say that this integer is equal to k. So now, instead of writing k in terms of x, let's just rewrite it such that we rewrite it as our x is in terms of k. But before we do this, we want to know that, wait, what's the range of this k? What's the range of this k? We know that this must be greater than, because this is an integer, because it's a square root of a number. So a square root must be bigger or equal to 0. Right? But a k, because we are 2022 minus something. Now that's something. Why? Because this part is always going to be greater or equal to 0, right? Because our x is a positive integer. So it is always equals to 2022 minus something. And that something must be greater than nothing. And hence our k must be smaller than 2022, the square root of 2022. Now, a quick estimation. What is the value of the square root of 2022? Now, a quick estimation. Now, we know that 2025 is equals to 15. It is at the square root of 2025 is equal to 15. So this is, this is 45, right? 25 is equal to 45, right? So we know that our k, because our 2022 is very close to our 2025, and hence we know that as long as k is less than 45, it is a okay integers. So we know that k can be ranging from 0 to 44. And you can check that if the 44 square is equal to 1,936, which is less than our 2022. Okay, so we know that the range of k. So how many different integers for k? It is actually from 0 to 44. So in here, there are 45 different values. Now this is important. Okay, so now let us rearrange it. We write it as the following. So our 2022 minus our x divided by 2021, hence it is equal to k squared. Now notice that because of our k having 45 different values, our k squared also have 45 different values. Okay, now let us rearrange it so that after rearrangement, we know that our x over 2021 is exactly equal to 2022 minus our k squared. And hence, we know that our x is equals to 2021 times our 2022 minus k squared. Now, don't forget that because our k squared has 45 different values, and hence this number has 45 different values, and hence the whole number has 45 different values. So we know that our x must have 45 different values for it to be true. So our answer is 45. Because for each k correspond to a unique x such that this is an integer. Okay, so our answer is 45. Okay, so what's the answer of? So some of you have asked, what's the answer of question 12? Down for question 12, our answer is the maximum value is actually equal to 0. So it can only achieve 0 when our x is equal to -7. Other than that, it will be always less than 0. So the maximum value is equal to 0 for question number 12. Okay. So now let's go to our next question, which is our question 15, a half of our lessons. Today is Sunday. Which day will it be after this date? Again, it is the same. What's the answer of question 13? Question 13 is equal to 12, right? Because we find out that if it is divisible by, if it needs to be divisible by 9, then the possible values of a plus b can only be equal to 3 or 12. But if it is divisible by 11, then the possible value of a and a plus b is equal to 1 or 12. So because we need to satisfy both conditions, that means that a plus b can only be 12. Now, it is not just its minimum value, it is its only value. Okay? Okay, so let's go to our question 15. So just like what we have discussed before in the previous question, all we need to do is just to figure out what is the remainder of it when it's divisible divided by 7. But in here, we would like to use our most important tools of doing this kind of things, which is our modular arithmetic. Modular arithmetic tell us some. Now, modular arithmetic will have some notation like this. We will say that these two numbers are equivalent. Now, they are not the same. They're equivalent. What does this notation mean? It means that the remainder of A divided by B, by M, is exactly the same as the remainder of B divided by M. So if that's the case, then we say that they are equivalent. Now, this is what it means. Now, in modular arithmetic, there is one very deep theorem which says that if the two numbers are equivalent, you can always replace one number by another when you are figuring out the remainder of the divisions. So in here, we make use of this theorem to see that while 1, 2, 3, when 1, 2, 3 is divided by our, when 1, 2, 3 is divided by our 7, so we will find out that it will have a remainder of 4. So 1, 2, 3, when divided by 7, has the same remainder as 4 divided by 7. They are all both equal to 4. So we can replace this 1, 2, 3 by 4. Okay, so it means, since that's the case, it means that our 1, 2, 3 to the power of 2, 3, 9 is equivalent to 4 to the power of 2, 3, 9. Or in other words, it will be equal to our 2 to the power of 4, 7. So 4, 7, 8. Okay. Now the later part is because they are identical, they are equal. Now the first equality, although this shouldn't be said to be equality, it should be said to be equivalent. Okay. So after this, we would like to rewrite this later part in the following. We would like to rewrite this later part as 2 times our 2 to the power of 4, 7, 7. Now, why we want, now, again, don't forget that this is when we are considering the divided by 7. When we are considering division by 7. Now, why we want to consider this? It's because this is very interesting by itself. Maybe I use another color. Because 2 to the power 447, this number, because 477 is actually a multiple of 3. It's actually a multiple of 3. So this number is exactly the same as 8 to the power 159. But why this is interesting? Because remember, 8 is equivalent to 1 when it's divided by 7. So we can replace this 1, replace this part by 1 to the power of 139. But this is exactly equals to 1, right? This is exactly equal to 1. So by replacing them, we know that the whole thing is equal. Now, hence in here, we can rewrite our equation in the following form. So it's a 123 to the power of 239. This is equivalent to 2 times our 8 to the power of 159. But this, the later part, this is equal to 1. We can replace it by 1, and hence we know that when it's divided by 7, it has a remainder of 2. Notice that these two are equivalent, as proven in here, right? These two are equivalent. Okay, so we know that our answer for this question is equals to 2. But is this our answer? Is this truly our answer? No. We only know that the remainder is 2. We still need to do the important job, which is we transfer from Sunday and then we consider 2 days later. So it will be, the answer should be Tuesday. Okay, the answer should be Tuesday. That's why I do not use a rectangle to emphasize answer. Now, don't think that okay, after all the calculation, then of the remainder, then we are done. No, we still need to give us what is the day of the week after this day. Okay. So let's go to our question 16. Each of the digit 1, 3, 5, 7 can be used only once to write a 3-digit number. Find the sum of all possible values of this number. Now, for this question, this question is actually extremely simple, but all you need to do is just list out the number and to see the pattern. Now the concept is very simple. Now let me rewrite this in here, because we have our 1, 3, 5, and 7, and we want to choose 3. Okay. So let us start from the lowest number. Let's start from the lowest number. So what are all the numbers that it can be? So it can be 1, 3, 5, and then it can be 1. Now let me separate them a little bit. Now for the reason that it will be very clear later. So it can be 1, 3, 5, and we can 1, 3, 7, or it can be 1, 5, 1, 4, or 1, 5, 3, and or 1, 5, 7. And then it can be 1, 7, 3, and finally 1, 7, 5. Okay. Now notice that these are all the possible values where we have our 1 as 100. As our 100 digit. So you can see that, well, in this case, so there are 6 possible ways for us to have a 1 as a 100 digit. But why 6? If you think about it, why 6? It's because in here, you just choose 2 amongst 3 numbers, right? You choose 2 amongst 3. But what is this? What's exactly the value of this? This is exactly our 3C2, right? This is a combinatorial coefficient, and hence it's equal to 6. That's why there are 6 of them. So actually, we don't need to list them out. We intuitively know that there are 6 of them. So there are 6 numbers of which we have 1 as the 100th digit. But how about for them to have 1 as its 10th digit? How many of them? Again, 6. Now I will list them out now, but you don't need to do that. Why? Because by combinatorics, these must be true. So they must be 315. So 317. And then it will be our 513, 517, and 713, 715, just like this. Again, these are all the possible way for each its 1 as its 10th. Again, it has 6 different ways, as shown on our left-hand side. So now, instead of adding this number 1 by 1, writing out all this number, now this is quite a number. The total number of that is 24 of them. So you can write them all out and then to try to sum it. And now it is doable, not undoable. It's manageable, I would say. But if you think about it, because it has 6 number in which it has 1 as its 100, this contributes to the total sum of 600, right? This contributes 600 to the total sum. In here, because there are 6 number in which 1 is a 10th, so it contributes again 60. So the same thing goes for our 1 as a unit digit, like this. It is just we are just doing the things. This is exactly the same. Right? Again, if we just sum up the 1, if we just sum up, we don't sum up all the numbers, we just sum up the 1. We can see that this contributes exactly 6. So for our 1 digit, it contributes exactly 666 to the final sum. Okay, so once you want to understand this, you can apply the same logic for 3, 5, and 7. Okay, so if you apply the same logic to 3, 5, and 7, what you get is the following thing. So our number one will contribute 666. Our number 3 also contributes 666, but this time you need to multiply it by 3. So our 1 is 1 times 666 plus 3 times 666. Again, for our 5, it will contribute again 666. And for our 7, it will again contribute 666. So the sum of all possible values of this number must be equal to 1 plus 3 plus 5 plus 7 multiplied by 666. And hence this would be equals to 16 times 666, or in other words, now again, someone have asked if the link of this video will be sent to Gmail. Now maybe it's Gmail. I'm not too sure because it depends on how you apply for this lesson. If you use WhatsApp, then we will send you through WhatsApp. If you apply in Gmail, then we will reply on Gmail. If you send it in message, then we will send it back to you by message. So it depends on how you apply for this class. So I cannot be sure I cannot sure which method that we will use. We will use the way that you contact us and send back the link through that way. So is this answer okay? Okay, let's go back to our questions here. So we are almost done. All we need to do is just calculate our 16 times our 666, and hence our answer is our 10656. So our 10656 is our answer. Okay. So instead of considering all these 24 numbers, we try to sum up each digit by digit. We consider the digit 1, and we consider how many 1 are there in the 100 digit, in the 10 digit, in the unit digit, and then we sum them all up, just the 1. And then we sum up just the 3, and then we sum up just the 5, and then we sum up just the 7. Okay. Okay, let's go to question 17. If k is this value, find the value of k. This is a good question of estimation. Again, let's talk about estimations. So in here, whenever we want to find a value of a number, first we want to find the range. Find the range of this number first. And then make it smaller and smaller. Make this range smaller and smaller until you get your number. Now, later on, we will talk that if the range is small enough, then you can use some other method for us to find out the number. Now, let's go back in here first. We know that our k to the power 7 is like this. Now, did you remind you anything? Now, you see, if it is 10 to the power of 7, if it is 10 to the power of 7, what is the answer? The answer will be equals to 1, 0, and then is 0, 0, 0, and then 0, 0. Okay. So of course, definitely, our k to the power 7 is greater than this. So in particular, k is greater than 10. No doubts about it. But how about 20 to the power 7? How about 20 to the power 7? Now 20 to the power 7, it is equal to 2 to the power 7 multiplied to 10 to the power 7. 2 to the power 7 is equal to 128. So it will be equal to 1, 2, 8, 0, 0, 0, 0, 0, 0, 0. Now, again, you can see k to the power 7 is actually less than our 20 to the power 7. So in particular, it means that our k must be between our 10 and 20. So in other words, k can be written in the following form. In which it is a 2-digit number in which its first digit must be 1. Okay? So all we need to do is to estimate. Now, the range is small enough. What we need to do is to estimate the last digit, this digit. How can we do that? Now, let us use our final ace in our sleeve, which is, let us consider its last digit. The digit is 9. What is the last digit? What's the unit digit of k such that k to the power 7 will have a last digit as 9? Okay. It actually does not have much choice if you think about it. So if our last digit is equal to 0, if the last digit are equal to 0, so how about it when it is raised to the power of 7? Well, the answer will also equal to 0, right? The answer is also equal to 0. Okay, so what about if our last digit is equal to 1, then the last digit is also equal to 1, okay? How about the last digit is equal to 2, then now it becomes 2 to the power of 7, but 2 to the power of 7 is equivalent to 2 to the power of 3 because it follows a cycle of 4, so it's equivalent to 8. How about 3? 3 to the power of 7 is equivalent to 3 to the power of 3, and hence it will have a remainder of 7. And if it is 4, then it have a remainder of 4. If it is 5, because all the power of 5 have a last digit that's 5, the same thing goes for 6. What about 7? 7, if raised to the power of 7, it has a remainder of, unfortunately, 3. How about 8? 8, when you are raising it to the power of 7, is equivalent to raise it to the power of 3, in which case that it would be equal to 8 times 6 is 4, so the last digit is equal to 2. And how about 9? 9 will have a last digit equals to 9. So if you check all this number, you will find out that actually there's only one number that satisfies our requirement. It is our 9, right? There's only one digit. Now, this is assuming that this number is actually a real, this number. In here, we are assuming that this number is actually a 7 power of a integer. Now, if it is not, then of course it cannot be. But since in this question it is given to you that this is really the 7 power of some integers, then we can use it to estimate what is this unit digit. Since we know the unit digit, we know the temp digit, and hence we know what exactly is this number. Okay, so this is how we get this number. Okay, so is that a question? If no, then now let's go to question 18. Now, question 18 is a problem about factor theorem. Now, the factor theorem says, now the factor theorem is very simple. In fact, it is very trivial to state out, but it's very, very useful. Now, it says that, well, no, what does that mean of the sentence? It says that, okay, our x plus 2 is a factor of our polynomial. But what does that mean? It means that this polynomial can be written as the multiplication of our x plus 2 to some other polynomial, right? So our 402x squared plus our 202x minus 406c, this number, this polynomial can be written as x plus 2 multiplied to some other polynomial. Now, this other polynomial we denote it by red. We have no interest to what exactly our red polynomial is. We just know that there are some polynomials here. Now, just by looking into this, the most important observation of factor theorem is says that, well, what if this part becomes 0? If this part becomes 0, then it forces, because now our number on our left-hand side, because it will be equal to 0 multiplied to something. But no matter what it multiplies, 0 multiplied by anything, it is still equal to 0. So we have a statement like this. If x plus 2 is equal to 0, which is our green one is equal to 0, it means that our 402x squared plus our 2022x minus 406c must also equal to 0. So if our green is equal to 0, our blue is also equal to 0. But what do you mean by green equal to 0? What do you mean by green equals 0? It means that our x is equals to -2, right? So all we need to do is just substitute x is equal to -2 into this equation, and we can find out that this must be equals to 0. So what is that substitution? So we can perform the substituting here. So because x is equals to -2, so our first term is just 402 times 4, which is 1608. And the next term is 2022 multiplied by -2 will be equals to -4044. And then finally, it will be equals to 406 to the power c. This is equal to 0. So let's rearrange it, and hence we get this equation. 406c is equals to our negative of 2436. And hence, if we divide both sides by 406, we get that our c must be equals to -6. C must be equals to -6. This is our answer. Okay. So this is the end of the number theory. Is there any questions? If no, then we will proceed to the next part, which is geometry. Okay. So now let's look into this. Given that our tangent x is equals to our this value, find the value of 1 minus sine x sine 2x. Now, there's something which we call a T formula, which says that we can always represent all the sine 2x in terms of tangent x. So if you know about T formula, you can do this. But in here, assuming that we do not know, now we want to find out by ourselves. In here, we will use a complementary triangle. Yeah, this is complementary. Now, what do you mean? Complementary triangles is a triangle that helps you to find out the values of the trigonometric functions of different, given that you know one of them. Now here, we have, now let's call our angle x here. We want this, now this is a right angle triangle. This is a right angle triangle. We want to construct it such that this angle is equal to x. Now, because of this, we know that tangent x, but what is tangent x? Tangent x is our height divided by our base, right? But if the height divided by our base is equals to 2/7, now can we just make it such that this is equal to 2 and this is equal to √7? Right? If it is 2, this is √7, then definitely our tangent x is equal to 2/√7. Right? But if that's the case, then we can find out our hypotenuse. Our hypotenuse will be equals to √11. So this is our complementary triangle. Once we recognize it, we can immediately find out that, oh, because of this, we know that our sine x must be equals to 2/√11. And our cosine x must be equals to √7/√11. Okay. But notice that if we know these two values, we can immediately find out our sine 2x, because sine 2x is exactly equal to 2 sine x multiplied by our cosine x. This is the identities. Sine 2x is equal to 2 sine x times cosine x. So by multiplying them together, we know that our answer will be equal to 4√7/11. So our answer will be 4 root 7 over 11. And hence, what is the value of this value, of this expression? It will be 1 minus this, but sine 2x is 4 root 7 over 11. So this would be equal to 11 minus 4 root 7 over 11. This is our answer. Okay. The complementary triangles are here so that you can find out sine and cosine easily. Now, if you do not use this, you can use the identities like sine square x plus cosine square x is equal to 1, and then you can try to convert them into a series of different numbers. This is completely fine. This is completely okay. It's just not that fast. Okay. So now let's go to our question 12. Question 20. Point 20. Find the shortest distance between our point 610 to our curve 3y minus 5x plus 15. Now for this question, there is nothing that we can talk about here other than using the famous equation of our distance formula, because this is a simple application of the formula. Now, given that we have a curve, given that we have a equation here, and then we given that there's a point here. Now, the distance formula says the following thing. Now, if we have a point x1 and y1, and we have a equation L such that it will be equal to ax plus by plus c equals to 0. So what is the distance? The distance will be equals to, it will be given by this formula. The distance will be equals to the absolute value of the ax1 plus by1. So we substitute x1 into x and substitute y1 into y, and then add c. So we are just getting the equation of our linear getting the expression for linear equation, but then we need to divide it by something, which is the root of a squared plus b squared. Now this is actually what we want to find out in our denominator is actually the distance of its y coordinate, the difference in the y coordinates of from our point to our curve. But then we will change the direction by divided by a squared plus b squared to get the exact value of the distance. Okay, now let's apply this in here. So we will see that our equation here now will be equals to the absolute value of 3 times negative 10 minus 5 times 6 plus 15, the absolute value of this, divided by our 3 squared plus 5 plus negative 5 squared. But of course, negative 5 squared is exactly the same as 5 squared, so we don't need to worry about it. Don't forget to take the square root of it. Okay? Don't forget to take the square root of it. Now this is the distance formula. Now now we would like to substitute it into this one. So the first part is 3 times negative 10 is negative 30 minus 30 plus 5, so it will be minus 45. But minus 45, the absolute value is exactly 45. And the base is equal to 9 plus 25, so we will be equal to root 34. Okay, so this one is our answer. Or we can write it in a much more appropriate way. in the same as 45 times root 34 divided by 34. And both of them are okay. So this, the ones on our right is a rationalized answer. The ones on our left is not rationalized. Okay, so this is how we find out the smallest distance from this point. Count round to 3 decimal places for question 19. I'm afraid not. I'm afraid not. You need to give the exact value of it. I'm afraid you cannot just round it up. Or do you mean question 20? Or question 20 because it already stated that you need to answer it in short form. So again, no. Yeah, because the equation is very interesting because it is 3y minus 5x, but the formula is very simple. You just replace our x1 into the corresponding x coordinate, and then we replace our y1 to the corresponding y coordinate. So in here, I'll just replace our 6 to our 5 here, and our -1 to our y here, -10 to our y here. So you don't exchange it. In fact, you replace it exactly, replace the x by the x coordinate of the point and replace the y by the y coordinate of the point. Okay, so this is our question 20. Okay, just let us look into question 21. Let's look into question 21. Find the area enclosed by this two, the x-axis and this two straight line. Now, whenever we see this kind of question, there are two major things two major methods that you can do. The one that I would recommend is that you try to draw out the diagram first. Now, notice that how this is very similar to the method that we will use later in question 22. So please compare this. Do remember to compare these two methods. Now we have three curves. One is our x-axis. Now let's draw our axis first. So now this is our x and y axis, and then we have our curve. So it is our x-axis, and the next one is x is equal to -y plus 24. So -y plus 24 is this one. If we draw our curve, it will be x is equals to -y plus 24 is this one. Because we know that when our y is equals to 24, then x is equal to 0. So we know that this curve has a y-intercept of 24, but it also has a x-intercept of 24. So it will pass through these 2 points. So for our curve, this curve is our curve, x is equal to -y plus 24. Okay, this is our orange line. Now, how about the next one? The next curve is 7y plus 2x plus 6 plus minus 6. So in case of y is equal to 0, to 2x plus 6 is equal to 0, and hence x is equals to -3. So we know that the x intersection of it is -3. So our -3 will be somewhere here. And for our y-intersection, is when our x is equal to 0. So 7y, it will be equal to 6, or y is equal to 6 over 7. So it will be very, 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 very low in certain sense. It will be somewhere like this. Six over 7. So all we need to do is just to find out the, now we have our x in our two curve here. The orange one is x equals to negative y plus 14. The green one is our 7y is 7y minus 2x minus 6 is equal to 0. Okay. So, and we are also bounded by our x-axis. So which means that the area that we would like to find is actually this area. The area we would like to find is actually this one. Now, just by the look of it, you can immediately see that, oh, this triangle have a base of what? Have a base of 27, right? Because it's extended from -3 to our 24. They have a base of 27. So as long as we can find out this height, then we are done, right? As long as we find out what's the height, then we are done. So in order to do this, we would like to find out the coordinates for this point. So in order to find the coordinates, we just substitute into here. So we know that for this coordinate, it needs to be true as our 2x is equals to our 7y minus 6. But we, according to our orange condition, on the condition 2x is also equals to our negative 2y plus 48. So we know that the path on our right, they are the same. So let us rewrite it as for the following. So our 7y minus 6 is equals to negative 2y plus 48. Oh, after rearrangement, so we know that 9y is equal to 54, and hence y is equals to our 6. So we know that y equals 6, and of course, we can find out our x is equals to the corresponding values, which is our 24 minus 6 is equal to 18. But this number is not important because as long as we know that the y coordinate of this point is equal to 6, then we know that the height must be equal to 6. So the area, we know our area must be equals to 27 times 6 divided by 2. So it will be equal to 81. So 81 is our answer. Okay. Now, every time you see the area bounded by a certain curve, it will be advisable for you to just draw the diagram out. Now, you don't need to draw as precise as me. All you need to do is just sketch it out and find out what points are there. Now all you need to do is to make sure that you get the x-intercept and y-intersection correct for each of this curve. And then if you sketch it out like this, then you are most certainly have got a very, very accurate number. Now, yes, I see. Yeah, this is already 8 o'clock. So the time for this lecture is almost over. But now I will keep on talking until the last part, or until the last question. If you have time, then you can stay to listen to this. If you do not have time, then you feel free to leave, and so that you can revisit it later after you receive the link for the videos, okay? So let's go to the next question. Let's go to the next question. Our next question is our question 22. For 4 points in our coordinate, this 4 points, find the area of the quadrilateral form that by using this 4 points as a vector, as a vertex. Now, every time you see a geometric problem like this, please do mark out this 4 points. Again, just like what we have done in question 22.1. Mark this 4 points out. So given this 4 points, we know, okay, so let us mark this 4 points out. Now, again, every time we do something like, now, you don't need to be very accurate. You just need to get this number right. Now, some of you may know that there are a formulas. I think it's so-called shoe length formulas. It's a very strange name that can help you to find the area of it by just plunking in the coordinate. But even if you have that formula, I will still recommend you to draw this point out, because even if you use this shoe length formula, if you want to use that formula, you need to know very well that what is the orientation of this point. And you can only know about the orientation of this point by drawing out the graph. So even if you want to use our formula, you still need to draw the point. So please do not skip for the easy part. So just you need to get things done. If you want to get things done, you need to draw this point. So we have A in here, B in here, C is 1 and -4, so it will be in here. This is our C. 1 and -4. And finally, we have our D, which is -6, 4. Now, once you draw your diagram like this, then you are almost done. Why? Because you can do it by some very simple geometrical process. So something as simple as what we have learned in the primary school. We can use a rectangle to circle them up, because all we want is the area within this 4 points, right? Within this 4 points. So instead of finding the area of this 4 points, we find out the area of the whole rectangle and then subtract the 4 right angle triangles in here, here, and here. So we subtract them out. Okay, then we will get our target area. So let's find out the area of the whole rectangle first. For the whole rectangle, you can see that now. Let us mark out our distance. Let us mark out our distance. Now, for our distance from the leftmost to the rightmost, because it's extended from -6 to 4, the distance of it is equals to 10. And for our width, it extended from the topmost to the bottommost. So it will from -4 to our 6, again, it is equals to 10. But later on, if you look closely, this side will have a length 4 because it goes from 2 to 6. And then this one, because it goes from 4 to -2, it will have a length of 6. So this will be 4. Now we can fill up all the length one by one, like this. So it goes from our -6 to 6 to 4. So this is 2. So this one is 8. And then we got have a -6 to 4. So this one, no, -6 to 1. So it will be equal to 7. And finally, this part length is of length 3. Okay. So we can make use now, and then this part we we go from -4 to 2, it will have a -6. So we can find out that, oh, the whole area of the rectangle, for area of the rectangle is equals to our is equals to 10 times 10 is equals to 100. Now for each of this right angle triangle, the topmost one is 6 times 4 divided by 2, and hence it will be equal to 12, right? And for our upper left-hand corner, it's 2 times 4 divided by 2, which is equal to 4. While bottom left-hand corner, it will be 7 times 8 divided by 2, it will be 28. And finally, it will be 3 times 6 divided by 2, it will be equals to 9. So the area in the middle of it, so it will be 100 minus 4 minus 12 minus 28 minus 9. And this is our answer. So if we calculate them, you can see that our answer will be equals to, now our 12 plus 90 is equals to 21. So it will be 100 minus 4, 100 minus 4 minus 21 minus 28. So the answer of it is equal to 47. So 47 is our answer for this question. Now, once you draw this out, and you can use very simple geometric tricks for you to solve it. So it is no need for you to use any formulas, especially for the shoe length formula, if you do not know the orientation of the point. Now, the other way of doing this is just separate this index into 2 groups. Well, you can calculate the area formed by this triangle. You can calculate the area formed by this triangle, and then you can calculate the area formed by this triangle, because these 2 triangles combine to form the whole quadrilaterals. And by making use of the shoe length formulas in that case, because the shoe length formulas in case of 3 points, you don't need to consider the orientation, as long as you take the absolute value. So you can do it in this way, and then you can find out the area. This is another method, but then again, why risk the miscalculation if you can safely plot out all the points? So now let's just go to our question 23. Let's 23, find the maximum value of this. Now, please compare this equation, this question. What we are doing here is very similar to our question 12, but the result will be much different. So please do remember to compare this with our question 12. So for our question 12, now again, we will rewrite this equation. We'll rewrite this equation by making use of our identities: sine square x times our plus our cosine square x. This is equal to 1. And now if we make use of this equation, we can replace our cosine square x by our 1 minus sine square x, and hence the whole equation will be equal to something like this. So it will be negative sine square x minus 5 sine x minus 10. Now it will be 1 minus, so we can rewrite it as negative sine square x minus 5 sine x minus 9, okay? So now what we want to do is to complete the square, right? Just like question 12, we complete the square. We rewrite this as the following. We rewrite this as negative of sine square x plus our 5 sine x over 2 plus our 25 over 4. Is that 25 over 4? No, it's 25 over 16. Okay, And hence because we subtract this, we need to add back to our constant in the front. So it would be equals to 9 times 16 minus our 25. So it would be equals to 119 over 16. Okay, it will be 119 over 16. Now after this, we will rewrite the whole equation as the following function. So it will be equal to sine x plus 5 over 2 and the whole thing square minus 119 over 16. Now, usually in this case, because we see that, oh, this is a square. So because a square is always going to be bigger or equal to 0, so this one will be always less than or equal to 0. So we know that the maximum value will be our constant, right? Yes, in line 3. So is there any question in here? Because we need to pick out 25 over 16 from our -9 and get it into our bracket. So that's why it will have a something. So because it used to be 9, it is 5 sine x. Yes, 5 sine x. But it's yes, it's 5 sine x. 9. I'm sorry. Yes, this is 5 sine x. Oh yes, it's 5 sine x. So this should be actually equals 4. Yes. Oh, oops. Yes. Thank you. So it should be, if we complete square to this would be 4 over 25. So this should be 9 times 4 minus 25. Also, this should be 11 over 4. Okay, so this would be 11 over 4. Okay. Yes, thank you. So this should be like this. Now, usually this would be the case that our terms in orange will be equal to 0, but not in this one, because let me ask a very interesting question. Can this be 0? Can this orange part be 0? The unfortunate answer is no. Why? Because sine is a function that's bound between 1 and -1. It can never achieve 5 over 2. So this one can never be equal to 0. So let us think about when will it be smallest? When will it be small? It will be smallest when the middle part of it. When the middle part of it will be the smallest in magnitude. But how is that possible? It is when they will be smallest. It will be smallest in magnitude if and only if our sine x is equal sine x plus our 5 over 2, because we are now here adding a very big number. If we want it to be small in magnitude, we want this one to be that our sine is equal to -1, right? So in this case, it will be small. So if the smallest value that you can achieve is actually 2 over 3. The smallest value that it can achieve is actually 2 over 3, not 0. Other than that, when you have another value of sine other than -1, it will be bigger in magnitude. So if after square, it will be a bigger number. All right. So in here, now after this, we can safely say that for our equation, cosine square x minus 5 sine x minus 10 is equivalent to is less than or equal to the things when the middle part, this is equals to 3 over 2. So it will be equals to -3 over 2 square minus 11 over 4. But this is exactly equals to -9 over 4 minus 11 over 4, and hence it will be equals to -5. So this a smallest value is actually going to be, the largest value is going to be negative. The largest value is going to be -5, because we want this to be small and magnitude, so that after taking up our negative side, this one will be the biggest, because you know that small in magnitude, but if a negative number, small in magnitude is of its largest value, because it's a negative, right? So this one is the least negative one, and hence it is maximum. So we get that then the maximum number is -5. Any other number, if you substitute it, we'll get a number which is greater than -5. So suppose you substitute our x is equal to, let's say, 0. So it will get a cosine square x is equal to 1 minus 0 minus 10, and hence it's -9. A smaller value than our answer, -5. Okay. So this is the question number 23. Please remember that every time you try to calculate the value using completing square, you need to make sure that the part within the square can achieve 0. If it cannot, you cannot assume that it's going to be 0. You need to find the exact value of the smallest one, or the maximum value of it. Okay. So now let us go to our question 24. Now our question 24 is the application of the Heron's formula. The Heron formula is very useful. The Heron formula for calculating the area of a triangle using only its 3 sizes. No angle, no height, only the values of 3 sizes. And then you can calculate the area of the triangle. Now, before this, we need to introduce a new parameter, which is called a new number parameter, which is called a half parameter. The half parameter, as you know, is the half of the parameter of the triangle. Okay, so the parameter is the sum of the 3 sizes, right? So we take half of them. So in this case, it will be equals to 6 plus 9 is 15 plus 13 is equal to 28. So the half of it is 14. Now, once we get this number, we can use our formula. The formula is like this. The area of a triangle is equals to the square root of s multiplied by s minus 1 of its length, and the s multiplied by s minus another length, and finally the s minus to our final length. And then we take the square root of the whole thing. This is our area. Okay. So if we use the result that we have calculated, so this would be equals to the root of 14 multiplied by 14 minus 6 is equal to 8, 14 minus 9 is equal to 5, and then 14 minus 13 is equal to 1. So it will be equal to something like this. 14 times 8 times 5 times 1. And by this, if you can see that there are in total 4 2. So we pick in 2 of them out of a square root. So the answer will be equal to 4 times root 35. And this is our answer. Now, Heron's formula is extremely useful, especially when we are going to calculate the area of a triangle in pressure in a very short amount of time. We do not need to know the angles of the triangle. We do not need to know the height of the triangle. We can only use the 3 sizes, and we can get this get this wonderful result using this formula. Okay, so this is question 24. Now let us go on to talk about question 25, our last part of this question, which is of combinatorics. Now for combinatorics, Carol drew 5 heads randomly for a box with 5 green and 7 blue. What is the probability that you at least you can draw 3? Now, so in here, so what do you mean by at least 3? So it means that either you draw 3 blue, or you draw 4, right? Or you draw 5. So you need to calculate each of them separately. You need to calculate the probability of each of them separately. Okay, so now let us calculate. Now, the probability of drawing 3 blue, which means that it must be 3 blue and 2 green. But what's the probability of drawing 3 blue plus 2 green? The probability is exactly equals to, you get 3 from the 7, so 7C3, multiplied, you get 2 from the 5, so it's 5C2, and then divided by all the heads. All the heads, we have 12 heads, and you select 5. So this is the probability. So we can calculate it one by one. So our 7C3, so will be 7 times 6 times 5 divided by 3 times 2.1 is 35. Our 5C2 is equals to 5 times 4 divided by 2 is equals to 10. And finally, our 12C5 is equals to 12 times 11. 12 times 11 times 10 times 9 times 8 divided by 5 times divided by 4, 3, 2, 1. So it will be equals to 792. Okay. So after this, we can try to cancel them out. For example, we can cancel out the 2. You can cancel out the 2, and then what we get is a much more simplified answer, which is a 175 divided by our 396. Okay, but this is only one cases. So now how about the second cases? The second cases will be our 4 blue and 1 green. Again, 4 blue and 1 green, just like for 3 blue and 2 green, it will be equals to we choose 4 from 7, and then we choose 1 from 5, and then divide by our 12C5. So again, it will be equals to, because 7C4, it will be 7 times, it would be exactly the same as 7C3. So it will be 35, but this time it will only have 5. It will be 35 times 5 divided by 792, and hence the answer is exactly half of the number that we get. So finally, we get all of them as a blue. So for these cases, we get nothing from our green. So it will be 7C5 divided by 12C5, and our 7C5 is equal to 7 times 6 divided by 2 is equals 21 over 792. So by combining all this number together, we can get the result. So the total, it would be equals to our 350 plus 175 plus 21. So it will be equals to 542 divided by 792. 546 divided by 792. So we can divide both sides by 2. We can divide both sides by 6. Okay, So if we divide both sides by 6, the first one is equal to 91, and the second one is equal to 132. 132, yes. And then we have nothing in common. Okay, so the total probability, it will be equals to 91 over 132, which is a lot if you think about it. But of course, it is most probable because the probability, because it is more likely for you to take blue hat and you only need to draw at least 3. So it's roughly half of them. The other half is you draw less than 2. So we have 3, 4, 5 for blue, or if we have 0, 1, and 2 for blue. So of course, drawing 0, 1, and 2 is less likely than our 3, 4, 5. So it is natural for it to be greater than half. Okay, so this is our question number 25. Now let's go on to question number 26. Find the number of positive integers such that this is true. Now in this cases, this was, again, please compare it with our computing square. Please compare with our computing square. No, so this is actually very similar. We can rewrite this as our x squared minus our 4x, no, plus our 4x plus 4 will be less than, or plus 4 will be less than our 169. Now we just rearrange it and adding 4 of this. But why we do this? Because our left-hand side is equal to x plus 2 squared, right? This is equal to x plus 2 squared, and our right-hand side, this is equal to 13 squared. So it says that x plus 2 squared must be less than 13 squared. So in other words, we know that our x plus 2 squared, our x plus 2 squared must be in between our plus 13 and minus 13, or in other words, our x must be in between negative 15 and our negative 11. Now, but this one is only given to you by our equation here. We still have another constraint, is the number of positive integers. So we also have another constraint, which is our x must be greater than 0. So if we combine these two together, we immediately find out that all the values of x is actually from our 1 up until to our 10. So how many numbers are there? 10 numbers are there. Okay, so this is our question 26. Question 26. Okay. So for question 27, now question 27 is actually very, very simple. All you need to do is to recognize what does that mean? Because we have three identical spoon and 6 identical forks in a row. So that means that there are 9 places in here. So in here, all we need to do is choose 3 places from our 9 places to place our spoon, right? But choosing 3 from 9, what does that mean? Choosing 3 from 9 is something that we are very, very familiar with. This is the definition of combination. So this one will have a value which is equals to 9C3, and hence it will be 9 times 8 times 7 divided by 6. So if we go on to calculate them, it will get our answer 84, right? 84. Okay, so this is our question number 27. It is actually very, very intuitive. So for question 28, if x and y are positive integers such that this value is true, find the maximum value of this. So in order for this number to be of a maximum value, you want our X to be as high as possible and our Y as low as possible. Right? So let us start with here. We know that because we know that our 13x, it must be less than our 13x plus 5y is equal to 396. So in particular, this means that our x must be less than our 396 divided by 13. So what's the largest value of x? So we can see the largest value of x. In here, we will give you a bound that x must be less than or equal to 30. Right? But now we can start from 30 and then work our way to find whether it's possible for them to exist. Okay, so let's find it in the hard way. X and Y. So if our X is equals to our 30, so what would be because we know that our 5y is actually equals to 396 minus our 13x, right? So given the value of x, we can find out whether there is a y for it. So for our x is equals to 30. Now it's very clearly see that that is impossible because our 396 minus 30 is equal to 6. This is not a multiplication, or this is not a multiple of 5. So it is impossible for x to be 30. So let us try another one. How about 19? Now if we go for 19, then it will have 13 increases, so it will go to 19 for 5y. Again, not impossible. So how about 28? Now, if it's 28, so you need to add another 13 in our 19, so it will be equals to 32. Again, not possible. It is only possible when it is 27, in which case it will be 45. All the things more higher than this is impossible because all the 5y's are not a multiple of y. Only when our x is equal to 27, we have our y. In that case, our y is equals to 9. So we know that our highest x is 27, our lowest y is 9, so our value is exactly equals to 18. So this is the maximum value of this function. Okay. Now, usually for this kind of equation, you can solve it in a general form. You can write out x is equals to 60, so it is equal to 27 minus 5s, and then our y is equals to our 9 plus 13s and something like that. But in this question, nothing. You don't need that sophisticated method. Okay. So now let's look at the next question. Find the number of sets of positive integral solution of a plus b is equal to 40. Now again, this one is simple. You can simply try to list them all out. You can simply try to list them out. Now this is not we introduced two methods. One is direct computation. Now again, this doesn't take much time. So we can say that, oh, if A is equal to 1, B must be equals to from our 1 up until our 39. So how many different choices are there? 39, right? How about if our A is equals to 2? If our A is equal to 2, B must be equals from 1 to our 38. So which means that there are only 38 choices. And if our A is equals to 3, then our B can only have 37 choices. It can only go from 1 to 37. So you can immediately see that by this, you can very easily see that the last cases is when A is equal to 39, and then our B can only have one choice, which is 1. So at that time, a B has only 1. So our answer will simply equals to our 1 plus 2 plus 3 plus ... until to 39. And this one is equal to 39 times 40 divided by 2, and hence it will be equals to 780. Okay, so this is our answer, 780. Now, this is not the only method of only way that you can compute this answer. The other way of doing this is by giving another integers. We say that A plus B plus C is a positive integer such that it is equal to 41. Now, in that case, then you can use acceleration to understand that this answer must be equal to 40C, because you are trying to divide 41 into 3 different positive integers. On the other way, by the H distribution, it is equal to 40C2, and hence it will be equals to 40 times 39 divided by 2, and hence it will get exactly the same answer. But the second one is a little bit sophisticated, so it sometimes you cannot get the thinking straight. It is much easier for you to just direct compute it. The number is not that great. Okay, so now let's go to our final questions. A fair dice flow 3 times. Find the probability that the sum of the number obtained is equals to 16. If you think about it, now this question seems impossible until you realize that there are not many ways for you to throw a 16. All right, so you can go for a 5 plus 5 or equals to 4 plus 6 plus 6. This is equal to 16. Or a 5 plus 5 plus 6, this is also equal to 16. But do you have any other way? No, right? There's only 2 ways. So there are only 2 ways for you to throw a 16. One is you throw a 4 and then you throw 2 6. 2 is you throw 2 5 and then you throw a 6. Other than that, no, this is not impossible. This is impossible to do it. So you just calculate what's probability of each configuration. So for our first one, all you need to do is to recognize there's only 3 different ways to throw it. Either it will be 4 6 6 or 6 4 6 or 6 6 4. So there's 3 ways, but again, you need to throw the dice 3 times. So it will be 6 to the power 3. So the probability will be 3 over 6 over 3, and hence it will be equal to 1 over 72. Now the same thing goes for our next one, because it will be 5 plus 5 plus 6. So either you are being 5 5 6 or 5 6 5 or 6 5 5. Again, there's only 3 different cases for it. So there are again another 62 over 1 over 62. So in combination, this will result in the probability equals to 1 over the sum of it, which is 1 over 36. Okay, so this is the end of today's lesson. Thank you very much for your attendance. I hope you have a wonderful day, and if you have any questions, feel free to ask. Other than that, see you next time.